Okay, in this example, we're going to simplify the expression and then state any excluded values. So this is a multiplication problem, indicated by the multiplication sign between the two fractions. And the easiest way I found to deal with multiplication sign or problems is just to factor everything and then reduce the factors before actually multiplying and distributing things out. So I'm just going to go around and factor each of my expressions, and we'll try to reduce things out. So in the top left, is there a common monomial? I'm going to probably have to write some stuff out here. There is a common monomial between the two terms. I know that x to the third goes into both terms. So I'm going to pull out x to the third. If I do that, that's going to leave me with x plus 7. And since there is no exponent with the x plus 7, I cannot factor farther. So I'm going to go ahead and write it down as my factored version. Next, I'm going to factor the bottom left. So we have 7x squared plus 35x. So there is a common monomial again between the two. So I'm going to pull that out off to the side. I can see the 7x goes into both. And then that would leave us with an x in the first term plus 5. And since, again, there's no exponent left inside the parentheses, that's all the farther we can factor this one. I'm going to continue kind of going in the same order around in a circle. So I'm going to go down to the bottom right now. X minus 8 doesn't have a common monomial. And since there is no exponent, we're just going to bring it down. Now we'll have the last one. I'll switch colors for that last one. So the last one here, there's no common monomial in all three terms. It's not one of the patterns, so we're going to go ahead and multiply first and last. So for the last one, we're going to have negative 40x squared. Some of the ways we can factor 40 are 1 and 40, 2 and 20, 4 and 10, 5 and 8. Has to multiply to be negative 40, but add up to be negative 3. So I think we're going to want negative 8 and positive 5. Since we don't have a leading coefficient, we can use our shortcut, skipping straight to the factors of x plus 5 and x minus 8. Now that everything is factored, we can get ready to cancel stuff out. So as I go from left to right, and that's usually how I proceed, I'll focus on the top of these fractions, working from left to right, and seeing if there's anything in the bottom of either fraction that we can reduce with each of the expressions, or each of the factors. So my first factor up to check on is x. Is there any x's in the bottom? Now I see the x over here, but this x is still connected by addition to something, so it's not a factor by itself. In fact, everything on the bottom of that second fraction is all one factor, the whole x minus 8. The x right here, however, is a factor. It's connected to other expressions by multiplication, so it is a factor, which means the factor on the bottom, the factor of x on the bottom, and the factor of x to the third on the top can cancel or reduce, turning it into x to the second. Since there's an exponent of 1 on the bottom, it will reduce it by 1. Next, I'm going to look at the next expression. I have nothing else that can reduce with that x. Now we're going to look at x plus 7s. Do we have any x plus 7s in the bottom? I have the 7, but that's not the same thing as an x plus 7. And there's no x plus 7s over on the other fraction either. So no x plus 7s that we can reduce here. Moving on, x plus 5. Well, there's an x plus 5 in the bottom of the first fraction. So long as it's on the top and bottom and only connected by multiplication, we are good to cancel. So we can cancel out these x plus 5s. We have one more factor to check, that x minus 8s. Are there any x minus 8s in the bottom? Well, yes, there is. X minus 8 right here is all one factor. So they will cancel out. So on this right fraction, we essentially just have 1 over 1 because everything's canceled out. And then on the other fraction, we have some extra stuff. Now to finish this problem, though, we have to write it as a single fraction. So on top of the first fraction, we have the x squared and x plus 7. And on top of the second fraction, we have basically just a 1 because everything canceled. Multiplying by 1 doesn't change anything. So the top of the first fraction is just that. The bottom of the first fraction is 7, and it would be 7 times the 1 that would be left over in the bottom of the second fraction, but 7 times 1 is still 7. And there's nothing else left in the bottom, so this happens to be the answer. Now this does say to also find any excluded values. So for the excluded values, we're just going to take each of the factors in the bottom of the fractions and set them equal to 0. So I'm going to include the 7 with the x, but you can actually do it separately if you want. So 7x equal to 0, x plus 5 equals 0, and x minus 8 equals 0. Got to do it for both fractions here. And then just solve each of those. So dividing by 7, so x equals 0, subtracting 5, x equals -5, and adding 8. So x equals 8. So again, what these excluded values are values that does not work if you plug them into the original expression, which means the two expressions are not equivalent if you try to plug these specific values in. Okay, so in this example, we're going to be simplifying the expression. Now, since it does not say anything about restrictions, we are going to be assuming non-zero denominators. Which is what causes the restrictions in the first place. Since we're assuming non-zero denominators, we don't have to worry about the restrictions. Now this problem here that we're simplifying is a division problem. Division and multiplication are almost identical. The only difference is how you start a division problem. To start a division problem, we have to multiply by the reciprocal, which I have been taught the phrase keep, change, flip, which simply means that we're going to keep our first fraction the same, change it to multiplication, and then flip the second fraction. After doing so, we just go ahead and factor everything like we did with the multiplication problem. Some of them are already factored for us. The top left one, b minus 5 and b plus 3, happens to be factored for us. The bottom left one, I think it just has a monomial. It looks like 4 goes into both terms. And that would put us at 2b plus 5. The bottom right with the 6, well, 6 is not a polynomial, so we cannot factor it in terms of polynomial sense. When I say factor in these problems, I'm referring to factor as a polynomial. I can technically factor 6, but not as a polynomial. And now up top, 4b plus 10, there's a common factor of 2 that goes into both, giving me 2b plus 5. Everything has been factored, so now I'm going to work my way from left to right, just checking to see if there's any common factors. So along the top, we have b minus 5 first. We do not see b minus 5 in the bottom of the first fraction, nor in the bottom of the second fraction. So b minus 5 will stay. B plus 3. There's no b plus 3 in the bottom of the first or the second fraction. Next is the 2. Now there is a factor of 4 and a factor of 6 in the bottom. They can both reduce with the 2, but we can't reduce them both. We can only do one or the other, but we could choose either or. So I'm just going to choose the 6 why not? They're on the same fraction, so let's go ahead and cancel that out. So the 6 and the 2 are both divisible by 2, so I'll divide them by 2, give me 1 and 3. And then the last factor on the top of the fractions is the 2b plus 5. Are there any 2b plus 5s in the bottom of either fraction? Well, yes. The first fraction has a 2b plus 5 in the bottom, which means they will cancel out. And that's the last thing that will cancel out. So we just have to rewrite our answer as a single fraction. If we do this, on top we have the b minus 5 and b plus 3 from the first fraction. The second fraction, all we had left is a 1, and 1 times anything is just wherever that thing was. So we don't have to worry about multiplying by 1. If it makes you feel comfortable, putting it out in front is okay. It's the same thing. It's just implied, so you don't really need it. Then in the bottom, we do have a couple things left. We have a 4 left over and a 3 left over. No binomial factors, so all we have to do is multiply the 4 and the 3 to get 12, and this would be our answer. You could also see the top distributed out, but usually this is fine. It's fine to keep it like this. And that's it. So in example 3 here, we're supposed to simplify the expression. And again, since it doesn't mention anything about stating restrictions, we're going to be assuming non-zero denominators for this problem. Now you can see this is a fraction on top of fraction. You do have to be very careful with these sometimes. Hopefully it's clear, but this fraction bar in the middle should be slightly longer than the others. Sometimes depending on what equation editor is used, it doesn't look that way, but since it is longer than the others, that means that this fraction on top is all one expression, and this fraction on the bottom is a separate expression. The fraction in the middle is just treated as a division sign, similar to the last problem. And the way we divide fractions is we keep the first fraction, we change it to multiplication, and then we flip the second fraction, or we multiply by the reciprocal. Afterwards, the process for multiplying fractions is just to factor everything and then see what cancels. So starting with the top left, 4x squared minus 1. Well, 4 is actually a perfect square. It's 2 squared. And so is 1. 1 is a perfect square. So the factors of 4x squared minus 1 would be 2x plus 1 and 2x minus 1 using the difference of squares pattern. Now for the bottom left. Bottom left, it's actually the same thing, just different factors. Both terms are perfect squares, so the factors are x plus 2 and x minus 2. As for the bottom right there, there's no common monomial and there's no exponent, so you can't factor it. And same thing with the top right, no common monomial and no exponent, so we can't factor it with polynomial sense. So we now have all the factors. Now we just have to find any factors that are shared and cancel them out. So starting with the top left here, are there any 2x plus 1s in the bottom of either fraction? No, there isn't. 2x minus 1 there is. So we'll cancel the 2x minus 1 here and here out. That would leave us essentially with 1 as a placeholder on bottom for the second fraction. And then going through, is there any x plus 2s in the bottom? Well, yes, there is right there. So those are going to cancel out as well, leaving us with essentially a placeholder on top. We'll finish it off just by writing it as a single fraction. So the 2x plus 1 will be on top of the first fraction, times our leftover 1, which isn't going to change anything. On the bottom, we have the x minus 2. So we're going to have x minus 2, but that's going to be times by the only other thing left in the bottom, which is 1. And 1 times x minus 2 is x minus 2. So there we go. That's a simplified expression. And since we're not asked about the restrictions, we're going to be assuming here, at least in this course, that we are dealing with non-zero denominators. So we don't have to worry about the excluded values unless we're specifically asked for them.